Hello guys, myself Prashant Kumar, working as assistant professor in Government Engineering College Bikaner in the Department of Information Technology. So today we are going to discuss about the pointer arithmetic and we'll get introduction about double pointers also. Okay, now let's start. So what is pointer arithmetic basically? So pointer arithmetic is nothing but in variables also we are doing like plus plus increment operation, decrement operation, plus 1 plus 2 if we are declaring a variable integer x and then we are doing x plus plus and x minus minus, x is equal to x plus 1, likewise this thing is like arithmetic operations on the pointer. So basically pointer arithmetic means arithmetic operations on the pointer. So now let's start with the example. Suppose you already know about the 1D array and now we will discuss the example. Suppose we have a array of size 5 and the value stored at particular indices are 1 2 3 4 5. So when we are declaring this, then this happens. So 5 boxes are there, elements at array 0 0, array 1 1, array 2, array 1, array 2, array 3, array 4, and we are supposing that address is starting from 1000. So base address of the array is 1000, then second element storage is 1002, 1004, 1006, 1008. So base address is 1000. So next element is starting from 1002. Here 1002. So how we can say 1002? It depends on the data type of the array. So here data type of the array is integer. So integer in 16-bit environment it takes 2 bytes. So 2 bytes means 1002. So next element will start from 1002. Likewise same array of 2 will start from 1004. So now we'll see the program. So here element and address is okay, but ARR will be holding the base address. So we are talking about the pointers here. So ARR will be holding the address of address of the first element, or we can say base address of the array. Now start with the example. Header file starting with main, integer variable I is declared, array of 5 1 2 3 4 5. Okay, now we are taking a pointer is pointing to a array. Here array name is a, so we can say our pointer p is pointing that array. So here in this example we have taken array name arrays. Now here array name is a, so we'll modify it to a. So base address of that array, this array is holding by a, and now pointer p is pointing the a. So p is pointing the same address. So p is holding the base address. So p equals to a and p is equal to address of a0. Both are same things. So next thing is what I am doing here. I am running a loop from 0 to 5 and I am printing the value of array indices. So suppose normally I want to print the array values. So what I will do, here we are using pointers, but simply what we'll use, instead of star p asterisk p, we'll use here, what will use here, a of 0, a of 1. Directly will be giving the indices and will be getting the values, right? But here in case of pointers, what we'll do, if we want to access the array indices, what we'll do, we'll just write star p or asterisk p, or this is used for asterisk operator used for dereferencing in the pointers. So what it will do asterisk p. Here p is pointing to what? P is pointing to a, or address of a0, a or address of A0. So base address. So P is pointing to address of A0 or A. Both are same things. Okay. So yeah, when we are writing asterisk P here, what it will do, it will print, what it will print, it will print 0th indices value, means it will print 1 when loop is running first time, means I value is 0, I is less than 5, correct, I plus plus, okay, then point, then we are going to P plus plus. P plus plus means pointer increment we are doing. What P plus plus will do, P plus plus, now P is pointing to A0. Next time where P will point, next time where P will point, next time P will point here after P plus plus, then again I value is 1 is less than 5, right, correct, I plus plus will execute later, okay, printf %d asterisk P. Again for one value again we want to type, means again asterisk P plus plus means pointer here, P is here, P is pointing to array of 1, and again we are doing asterisk P. What it will print again, it will print array of one value, array of one value is 2. In this array we will be checking the values, okay. Now where P will point after doing P plus plus, again yeah, P again P plus plus, so where P will point here, so now P is pointing to array of 2. Again what it will print, asterisk P. Asterisk P means now P is pointing to array of 2, and value of asterisk P is here 3, means well asterisk P means value which is stored at P, which is stored at where P is pointing. P is pointing to array of 2, the value stored at array of 2 will be printed when we will write asterisk P. Now again P plus plus, what P plus plus will do, P plus plus, now it will point to ARR of 3, and then asterisk P again, then array of 3 value is here 4, right, again P plus plus, then what it will do, it will again it will point ARR of 4, ARR of 4 means asterisk P means value is 5, so what it will print 5, again P plus plus, then what P plus plus will be, what P will be pointing now, so now P will be pointing the memory address 1001010, because we are talking about we are talking about integers, so it will increment by 2 bytes. So yeah, here how things will go on. So here we are in two things are important. First thing is increment is going to be done by 2 bytes only because of the data type. Here data type is integer, so we are incrementing 2 byte. First point. Second point is asterisk P. Asterisk P means dereferencing operator. Here we are basically what we are doing, we are printing the value of an array using loop and using pointer also. So pointers dereferencing is happening here again and again. So nothing but pointer increment is happening, and again we are dereferencing the pointer. Yeah. So going to the next slide. So what is pre-increment or what is post-increment? Earlier also we have discussed about what is pre-increment and post-increment in case of variables. Post increment means if you are using a printf statement along with the post increment operator in the same printf statement, like I am writing printf %d x plus plus. Suppose x value is, earlier x value was 1, x is equal to 1 we have assigned earlier. So what it will print? It will print 1 only, and later the value of x will be incremented to 2 after execution of that printf statement. Like, so pre-increment means effect is early, pre-effect is going to be happen, and post increment means after the post effect will be going to happen. So in case of pointers, okay, let's see. First of all, we'll talk about the pre-increment. So when we are writing asterisk plus plus p, what it will do? It will increment the pointer, then it will take incremented pointer value. Suppose in the example here we are taking an array of size 3, value stored at indices are 10, 11 and 12. Then we are declaring a pointer asterisk p, pointer we are declaring. Now pointer, where pointer is pointing? Pointer is nothing but pointer is pointing to the base address of the array. Now what we are doing? We are printing that asterisk plus plus p. What it will do? Printf %d asterisk plus plus p. What it will do? First of all, it will increment the pointers. First pointer was pointing 10. Now pointer, after doing this, when will counter this operation, what pointer will be pointing? Pointer will be pointing to the 11, and then we will take the value of the incremented pointer value. Means pointer will be pointing to array of 1 or 11, and the value of that incremented pointer is 11. So what it will print? 11. So basically here what is happening, we are declaring a array value is 10, 11 and 12. Initially pointer was pointing to base address here, and after we are saying asterisk plus plus p, what it will do? First it will increment the pointer, means it will not point here, p will be pointing here, and the value at value where p is pointing will be printed in this case when we are writing this. So where p is pointing to the 0, 1 or 2 index. So total indices are 0, 1 and 2, so total 3 indices are there. So p is pointing to the 1th index. So what is the value stored at 1th index? That is 11. So what this print will print? It will print 11. So do not confuse. So this is nothing but simply we are incrementing the pointer value. So pointer will be pointing to the next index and will be printing the value of the next index. So next point is, when we are writing asterisk p plus plus, means post increment. We are talking about now post increment, that is the pre increment thing. Now we are talking about the post increment. Post increment is nothing but when we are writing asterisk p plus plus, then what it will do? Take the pointer value and increment the pointer. Suppose when we are writing this in any example or in any program, then what it will do? First is let us take above example only. So in the above example, 10, 11, 12, p is pointing here only. So in case when I am writing this asterisk p plus plus, then what it will do? It will take value of 10. It will simply print 10 in this. When we will execute here, that thing will change. It will be asterisk p plus plus. Then what it will print? It will print 10 only. And after printing this thing, what it will do? It will increment that p to the next indices. So in case of pre, first we are incrementing, then we are taking value. But in case of post increment, what we are doing? First taking value and then incrementing the pointer, right? Okay. Now Okay, let us discuss about operators in detail. What p plus plus is doing? When we are declaring a pointer and we are doing p plus plus, what it will do? It will move the pointer to the next data item. Next data item means, in case of arrays, right, what is happening, we are incrementing the pointer, so pointer will be incremented, pointer will be moving to the next data item when we are writing p plus. So number of bytes moves on the depends number of byte of the movement, means when we are writing p plus plus, so in a case of integer array we are moving by 2 bytes, but suppose I am taking a character array, so it will move by 1 byte. So I am taking float array, so it will move by 4 byte. So 1 p plus plus will be incrementing according to the data type. So data type is integer, it will increment 2 character, 1 byte, float 4 bytes. Okay. So number of bytes will be depending on the data size, data type. P minus minus move the pointer to the previous item. Same like when we are doing minus minus, then it will be moving in array, it will be moving from 1th index to the 0th index base address. So the movement again will be depending on the data type. Suppose in case of array, now my pointer is pointing here, so I am doing p minus minus, where it will print, it will start pointing, not print, pointing. So p will be pointing here instead of here, so this is decrement, this is decrement. So again, in case of integer array, I am talking about integer array only. In case of integer array only, I am reducing it by 2, size 2, or in case of float by 4. In case of character, it will move by it will move by 1 byte. Okay. Okay. Now we'll talk about p equals to p plus 3. What is going to do? This statement is going to do 3 position ahead of p plus 3. Means suppose we have an array like this. Our p is pointing here. Initially our p is pointing here. When we are doing p is equal to p plus 3, where p will be pointing increment by 1, p plus 1 here, p plus here, p plus 2 here, p plus 3 here. So what our p will be pointing now after p plus 3, it will be pointing here. So it will be pointing here. So size can be anything, size can be like depends on the data, movement will be on the basis of the data type, right? Again p is equal to p minus 3. We are doing p minus 3 means again we are going to the beside of p, means we are moving backward. So how much again depends on the data type. Now the important point is p is equal to p1 plus p2. P is equal to p1 plus p2. Suppose for example, I am taking here my p1 pointer is pointing here. Suppose, let us say p2 is pointing here. Now what I am doing, I am assigning a pointer again. P is a pointer, so let us say p is pointing here. So now p is pointing here. Now what is saying, p equals to p1 plus p2. P1 plus p2 means where p is pointing, p1 is pointing and p2 is pointing. So when we are adding p1 plus p2, what it will do, p1 plus p2 will be adding the addresses, and again where will be going, will be going to some random address or somewhere else. So it doesn't mean anything. So what it will in compiler, it will give error. So it is a there is no meaning associated with this statement, so it is not possible, it is not allowed. So it will give a error when you will do such type of operation. But in case suppose where whenever we are executing p equals to p2 minus p1, this is allowed, and what it will do, so it is having a meaning. So what is the meaning of this thing? It will be calculating the distance between the two pointers. Suppose a pointer is pointing to address 2008 in array also. Suppose here one pointer is pointing, here one is pointing. I want to calculate the difference. So difference is 2. So now pointer is pointing to 2004, and here suppose 2000, and here this is 2002. Integer we are taking, and 2000, 2002, 2004 nothing but addresses. So first indices address or base indices 2000, again next indices means array of 1 2002, so it is the initial address. Again for third indices it is starting from 2004, because where the data type is integer, size is 2 byte, increment will be for 2 bytes only. So it now suppose our p2 is pointing here, and p2 is pointing, sorry, so suppose our p2 is pointing here and p1 is pointing here. So what is the difference? So difference will be 2. So it is useful when we want to calculate the difference between the 2 pointers. So it is useful when we are calculating the difference between 2 points. So it has a meaning, but that earlier statement like p1 plus p2, it do not have any kind of meaning. So now move on to the next one. Why type of a pointer is required? Type means data type. I am saying again and again. So when we are saying, when we have already discussed about a point like the type of the pointer will be, I mean if we are holding a address of an integer variable, then type of the pointer will be integer. So a pointer will be holding the address of the another variable which is of same type. We have already discussed about it. So now why a pointer type is required? As I have already discussed with you, when we are doing increment and decrement operations, or suppose we are doing arithmetic operations. So like in previous slide also I have discussed how much that when we are doing p plus plus, how much it will increment, or when we are doing p minus minus, like how much it will decrement. So it will be depending on the size of data type or type of that pointer. So why it is important? So in case of increment decrement operation or arithmetic operations, it is important. Second thing is typecasting is also a problem. So when we are we'll discuss it using an example. Suppose we are taking a variable a, value assigned is 15, character b, value assigned to it is g. When we are taking character pointer, so I am taking here character pointer. So now what I am doing in the next line, I am assigning p equals to address of a. P, our pointer, is type of character and a is type of integer. So I am assigning address of a integer variable to a character type pointer. That is not allowed. So what will be what we have to do here? We have to do the typecasting. P equals to character asterisk and bracket close and address of a. This is how we will do the typecasting of variable here for the pointer. To store the variable, to store that variable address in the pointer, we have to convert this thing into character type. So this is also a problem. So that's why type of the pointer is important. So if we'll do like this, then it will create a problem. But again, if we are to solve the issue, we have to do typecasting like this. But again, when we are printing printfc, so remember this thing, when printing %c asterisk p. So now where p is pointing, our p is pointing that typecasted a value, but a value is 15 of integer type, means it is integer type, means in memory it will be taking 2 bytes, but when we are printing I am using %c asterisk p. So p is pointing now P is pointing, where P is pointing? P is pointing to that 2 bytes. These are 2 bytes, first byte and second byte, suppose say. Now P is pointing here, this. So what it will print? It will print, in case of %c I am saying, what it will print? It will print the first byte only. So it will not take the integer value second byte. So it will be printing on the first byte only. So when we are using %c for integer, I mean after typecasting also, it will be printing on only the single byte. Yeah. Now move on to the next slide. So yeah, now again void data type of the printer, we will talking about this. So it is a generic data type of undefined size. So it is also a kind of data type. So the size for void is not defined, right? Size for void is not defined. Suppose we'll understand it. We'll understand it using example. Suppose I am taking a pointer void asterisk p. What type pointer I am taking here? So when integer a 10, okay, now we are taking a variable, value assigned is 10, float b 15.7, it is also okay. When we are assigning p is equal to address of a, p is equal to address of a. Now what we are doing, p size is undefined, and we are p now what will happen? P will be pointing the address of a, which is of integer type. So that is allowed. How that is allowed? Because void we are giving already void type pointer, so it will be it can point to any kind of data type variable. So it can point integer, it can point character or float or anything. But at the time of dereferencing, when we are dereferencing, suppose I want to print the value which is pointed by p. So at the time of dereferencing, when I am using %d in the printf statement, so by default I am considering this thing as %d. I mean %d is used for integer, but the size of void is not known. I have already told you, size is undefined. So at the time of dereferencing, I am using %d, so that is not allowed. So whenever I am directly using asterisk p, that is not allowed. So when I am using %d asterisk int asterisk p, now here what I am doing here explicitly I am converting the pointer type into that dereferencing thing into explicitly into integer type. So now it will be printing so the void can printf %d asterisk int star p. What it will do here, typecasting is done. Now it is okay. It will be printing the integer value. So it will be printing 10. But in above printf statement, it will give the error. But in the second printf statement, explicitly we are doing typecasting, and here it is correct. Here size is defined, %d is justified, because here we have converted that pointer into the pointer dereferencing into integer type. Okay. So in case of void data type, what is happening? We can it can point to the any data type address, any data type variable address. So but we can, at the time of dereferencing, we have to explicitly say that it is of type of integer or type of float or type of double, same thing. Suppose I want to dereference b value, suppose here I am giving p is after this. Again for second example I am taking pointing b value is 15.7 at the time of dereferencing. Suppose I am directly typing asterisk p, it will give error. To type to solve this error, we have to write asterisk float asterisk and then p. Then if we are using %f or lf, it will be printing, what it will be printing? It will be printing 15.7. yeah. So it can point it can it can refer to address of any type of variable, but at the time of dereferencing we have to take care of this thing. Next thing is now we will be talking about the double pointers. So what is the meaning of a double pointer? So meaning of double pointer is nothing but we are taking why we are taking a pointer? We are taking a pointer to point a address of some variable. Now suppose again I want to reference the address of that pointer variable. So again I want to access the address of that pointer variable. So to store the address of the pointer variable, again we need a pointer. So a pointer is nothing, a pointer is pointing again to a pointer. So the thing is, first pointer is used to store the address of a variable and the second pointer is used to store the address of the first pointer. So the same thing, okay, I will tell this thing also using example. And first we'll talk about the second point. How to declare a pointer to pointer in C. So declaring a pointer to pointer is similar to declaring pointer to pointer is similar to declaring a pointer. Single pointer and double pointer is I think similar kind of thing. Okay, but syntax is different. Yeah, but concept is same. The difference is we have to place an additional asterisk before the name of the pointer. So that is the difference. The syntax for the double pointer is asterisk ptr. Ptr is nothing but name of the pointer, first asterisk and second asterisk. So double asterisk means double pointer here. So integer type of double pointer we have declared here. So now consider this example. Now before discussing this example, I want to discuss something with you. So let us see the diagram. So here what I have said earlier, that a double pointer is nothing, a pointer is holding the address of another pointer. So here first pointer, okay, single pointer, we know all that variable is here, first pointer is p1, second pointer is p2. So what is happening here? So p1 is holding the address of, so in the memory that block is created, variable name is here, the address of the block is here. So what p1 is containing for p1 also, address of the p1 is this and value of the p1 is this. So what will the value of p1? Value of the p1 will be this only. For pointer p2, what will the value of p2 is, what will the value of p2? Value of the p2 will be this thing only, address of p1 only. And the address of p2 is here and the name of the pointer is p2. So this is the same thing. So this is the output of the, how the things will be going on. It is the output of of the previous slide program. So first we'll discuss the program and then again we'll go to the diagram. So start with, okay, main integer variable, okay, asterisk pointer p1, simple pointer I am declaring, and that is double pointer asterisk p2. Now p1 is pointing to a, p1 what is address of a, p2 is pointing p1, and what I am doing here, printf address of a %u address of a. What is address of a? Address of a is nothing but in the next slide, okay, you can see address of a is 2686724 and the value of a is, if I am writing here address of a, what is the address of a? 2636724. So what it will print? It will print that address only. Second statement is address of p1. What is address of p1? So address of p1 is, what is the address of p1? So address of p1 is 2686 7 to 8. Yeah, that is address of P1. Third thing is P2, address of P2. What is the address of P2? Address of P2 is 2686732. Okay. Now coming to the next thing, printf at address value stored by P2. So value stored by P2, I am writing P2. What it will print? It will print asterisk P2. It will print asterisk P2 whenever I am writing. Then what will print? The value stored at the place where P is pointing. So P is pointing to P1. The value stored at P1 is 2686724. So what it will print? It will print the value stored at P1. And that final thing is we can say, yeah, value at the address stored by P1. What it will print? Asterisk P1 I am saying. So what it will be printing? Asterisk P1 means the value stored at where P is pointing. So P1, where P1 is pointing. P1 is pointing to that variable A, and what the value is stored here? It is 10. So what it will print? It will be printing 10 only. So it will be printing 10 only. And that last one is value of static P2. Again it will be, so what will do? It will do the P2 double dereferencing here we are doing here. So double dereferencing, when we are writing, suppose I am writing asterisk P1, it will be giving the value of A. And in case of double pointer, same thing, like it is in case of single pointer we are writing asterisk P2, but in case of double pointer we will be writing asterisk P2. So these are both doing the same thing. So it will be printing the 10. So P2 equals to address of A. P2 equals to address of A. Now P2 will be pointing to this, and again what will print? Will print %u or P2. P2 means what? What actually P2 is? No. In case of P2 is pointing address of A, and I want to print P2. So the value contained by P2, yeah. So value contained by P2 is 2686728. 2686728. Okay guys, let us talk about this printf again. So P2 equals to address of A. So that thing, P2 equals to address of A. Okay, we are not talking about single pointer here or simple pointer here. I am talking about double pointer here. So here what we are doing our P2, or we can see in the next slide, our P2 is pointing here, that I have already explained you. So that is not possible. So that is not in case of double pointer, P2 can point P1 only. It cannot point directly A, right? So this is not possible. So do not get confused. So I have again told you that when P2 equals to address of A is written, it means it is invalid. And again what I am doing in printf, what I'm doing here in printf, I am printing P2. So P2 equals to address of A, it will give a error. So here this is for comment. So this is not a it will the program, if we are typing this complete program, this thing will not run. If we are removing this thing, or just remove these two lines, P2 and printf, right? So remove these lines, then program will definitely work. So p2 equals to address of a, that is not possible. So in case of double pointers, you can, our double pointer will be pointing only p1, so it cannot point directly p. So that is the important point. So earlier, because of confusion, like I was thinking that single pointer is only there, so I have discussed about this. So but now I am correcting this thing. Okay, remember this thing. So yeah, that is the complete scenario. Here we have used again, p2 is pointing p1 only, p1 is pointing a only, so p2 cannot point a directly. So yeah, in case of double pointers, yeah. The references I have used here, Dennis Ritchie and Geeks for Geeks, Study Tonight, and some of the handouts also. Yeah, thank you so much. In the next lecture, we'll be discussing about the arrays in detail. I mean 2D array in detail. Then again we'll be discussing about the pointers and 2D array, and then pointer to a function. And in the next video lectures, we'll be talking about the file handling and all. Yeah, for now that's it. Thank you so much.